Now, let's learn the concept of relative atomic mass in this video. Now, I will start by explaining with an analogy. Pay attention. If I place, let me say, 10 grams of stone on this scale, you know that it's going to bend this way because there's nothing here. Good. If I say that, oh, I want to measure, let me say, I need 10 grams of vegetable at this side. Are you there? I want to put, or let me say, sugar cube. 10 grams, I need it here. You know, I'll keep on placing sugar cube, sugar cube, sugar cube, sugar cube. Now, if you now get to a point whereby the scale is now like this, it's no more bending at any side again, who can tell me what will be the mass of sugar cube here? The mass of sugar cube here will actually be what? Be 10 grams. Hello, remember that this type of scale here, it does not have any reading where I saw 10 gram. But the idea is that there is 10 gram here already. I'll keep on placing sugar cube on this side till when the scale balance. At that point where this scale is at equilibrium, that shows that what? The mass of sugar at this side is 10 grams. And take note that what? This 10 grams here is what? Is relative. Is what? Relative. Let me tell you something. Whenever you are measuring something with respect to another thing, we use the word relative. Okay? Because we are measuring this 10 grams with respect to this 10 gram here, so we say what the mass is what is relative. Now pay attention. Is it possible for me to measure the mass of an atom on this scale like this? No, that is very small. It's not possible. So what do we do here? Now pay attention. Now you see, to measure the mass of an atom, to measure the relative mass of an atom, you see, we have a standard scale we use, and that is carbon 12. What do we use? Carbon 12. We use carbon 12. I'm coming. The standard we use here is what? Is carbon 12. I'm coming. Let me just write it like this. We use carbon 12, exactly. Why do we call this carbon 12? Because carbon has a mass of 12 units. That's why it's called what? Carbon 12. Good. Now, if I place another carbon 12 here, everybody check. What will happen? It's still at equilibrium. Good. What of if I come here and I divide this carbon 12 into 12 pieces? Into 12 pieces. Let me say I divide into 12 pieces like this. All together? Hello. 1, 2, 3, 4, 5, 6, 7, 8. Okay, sorry. Let me do it this way. Exactly. Now, you know, this is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, this is also carbon 12. Are we together? Now, look at it. Carbon 12 is there full. Carbon 12 is there divided into 12 pieces. Will it still be at equilibrium? Yes, 100% to be at what? At equilibrium. Now, pay attention to something. You see, in chemistry, the mass of one of the atom of carbon 12, that is, if I take one piece of this carbon 12, the mass of one of this atom of carbon 12 is called what? Is called 1 atomic mass unit. All together, that's what we call what? 1 AMU. All together, that's the mass of one atom of carbon 12. That was 1 atomic mass unit. All together, good. Now, let me now say that, okay, I want to measure the relative atomic mass of oxygen. Pay attention. I want to measure the relative atomic mass of oxygen. And oxygen here, I put oxygen here, O. And now observe that this thing is still bending this way. Remember, this is what? This is oxygen. This is oxygen. I want to measure the mass of the atom. Now check. But oxygen is bending this way. But what will I do? Pay attention. Since it's bending this way, you know, it means that what? I have to add more atoms of carbon 12, right? So if I keep on adding, and now observe that if I add 16 of one atom of carbon 12, that is when this scale will be at equilibrium. That means that the relative atomic mass of oxygen is equals to what? 16 atomic mass units. I will explain that again. I observe that if you place the mass of oxygen atom here, this scale will bend this way. It means that what? It is still heavier than carbon 12 in general. So what will I do? I'll keep on adding the mass of the atom of carbon 12 till when this scale will be at equilibrium. Now, if I keep on adding the mass, I observe that if I add 16 of one atom, like if I add 16 atoms of carbon 12, are we together? If I add 16 atoms of carbon 12, that is when this scale will be at equilibrium. Therefore, the relative atomic mass of oxygen is what? 16 atomic mass units. Let's use another. Now, let's now place sodium on this scale. Don't forget that what I have at the left hand side is carbon 12, and I told us that what one atomic mass unit, sorry, I told us that what one atomic mass unit is 1/12 part of carbon. Altogether, that is the mass of one out of the 12 atoms of carbon 12. That is one atomic mass. That is, if I divide carbon 12 into 12 pieces, the mass of one is what we refer to as what one atomic mass unit. Altogether, just like in physics, the SI unit of mass is kilogram, but here the SI unit we use there is what AMU, atomic mass unit. Now, if I place sodium on this scale, sodium atom on this scale, I will observe that this scale will actually tilt down this way like this. That shows that what the mass of sodium is what is more than that of carbon 12. That is why the scale is not at equilibrium. Now, what will I do to balance the scale at equilibrium? I'll keep on putting the atoms of carbon 12 till we have a balanced scale. Now, I now observe that what I keep on adding the mass of carbon 12. I keep on adding what the atoms of carbon 12. I now observe that if I add 23 atoms of carbon 12, that is when this scale will be at equilibrium. So imagine, I don't know the mass of this, but I observe that after adding 23 atoms of carbon 12, the scale is at equilibrium. That shows that the mass of the relative atomic mass of sodium is what 23 atomic mass units. Again, I observe that placing the mass of sodium on the right hand side of this scale, the scale bend this way. That shows that sodium atom is heavier than the atom of carbon 12. Then to balance the scale at equilibrium, what will you do? You keep on adding the mass of carbon 12 till when the scale will be at equilibrium. So we now observe that what after adding the atoms of carbon 12 23 times, are you there? After adding it 23 times, then I got that what, oh, this scale was at equilibrium. Therefore, the mass of what sodium, the relative atomic mass of sodium is what 23 AMU. Now, how do we now define the relative atomic mass? It's very simple. It's just telling you the number of times one element is heavier than the atoms of carbon 12. That's all. Simple. That is, this one is heavier how many times? 23 times. If you did one for oxygen, you have 16. That's just it for what? Relative atomic mass. That is the number of times the average mass of one atom of an element is heavier than 1/12 the atoms of what? Of carbon 12. That is, how many times is this Na, sodium, heavier than one of these atomic mass units? It's heavier than it how many times? 23 times. That's why we have to place this one 23 times to balance the scale. So that's just it. So that's that for that. So thanks for watching. Now let us look at some calculations that involve this chemical formulae. If you've got to this side, sincerely speaking, you've really tried. Best of luck. So keep on moving and refer this video to your loved ones so that they can learn from this. They can also gain from this opportunity. So let's look at what we call relative molecular mass. What I explained previously was what? Relative atomic mass. Now, when we are talking about relative molecular mass, RMM, here we are calculating it for compounds. Are we together? That is, for example, now we are having a compound like CaCO3. The relative molecular mass is just the sum of the relative atomic masses of all of them. That is just it. So let me give us an example. Now, if I say calculate the relative molecular mass of let me say of CaCO3, and you'll be given the atomic mass of this, and this is what you have. Okay, so let's see what you are going to do. Solution is very simple. We have CaCO3. So the easiest way for you to do is that what you calculate the one for calcium, add it with the one for carbon, add it with the one for oxygen. But oxygen here, there are 3 in number, so I'll say 3 and the one for oxygen. So the atomic mass of calcium is 40, carbon is 12, oxygen is what? 16. Just give me 40 plus 12 plus this is 48, and everything here will give me 100. That's the relative molecular mass. Remember, relative molecular mass does not have units. You don't have to put units. Some people use gram per mole, but that's wrong. But just leave it as 100. There's no issue. Okay, let's look at another one. If you are asked to calculate the RMM of this compound, Al2SO4 how will we do that? We'll be given Al to be 27, sulfur to be 16, sulfur to be 32, and oxygen to be 16. Are you there? So let's go. So I have now check Al solution, Al2SO4, Al2SO4 3. Remember, I have 2 aluminium. Also, if you look at sulfur here is 3. This 3 here outside is talking to you, so sulfur here is 3. And if you check, oxygen is how many? You know, mathematically, if I tell you 4, 3 bracket 4, what does it mean? 3 times 4, and that's 12. Same thing you will do here. I have 12 oxygen. So let's go. I have 2 times 27. 3 times sulfur is 32. And the oxygen is 16. So let's go. This one will give us 54. This one will give us 96. Are you there? Because this one will give us what is, wow. Okay, let's go. So what this is, I have 12 times 16. That's 192. So if I add all this together plus 96 plus 54, that will give me 342. So I have 342. So that's how to calculate relative molecular mass. Nothing much. So thanks for watching this aspect. Now, look at this problem. A metallic oxide M2O3 has a relative molecular mass of 160. Calculate the relative atomic mass of M. M is an unknown metal. We don't know M at all. So we have to find M. Okay, no problem. Now, if you look at M2O3, how do we calculate the relative molecular mass? We'll say 2 multiplied by M plus 3 multiplied by oxygen. Addition of these two will give us the relative molecular mass, and that is 160. So I have 2M plus 3. Oxygen is 16. Remember, if they don't give you, remember, oxygen is 16. So I have 16, then equal 160. What is there is 2M plus 48 equal 160. I have 2M. You solve this equation. When plus 48 comes here, it becomes minus 48. Therefore, from here, what do we have? We have 2M equal to, what is 160 minus 148? 160 minus 48, rather? 112. So, to get the value of M, we divide both sides by 2. Divide both sides by 2, what do we have? So, M equal to 112 divided by 2. So, we have 56. So, we have 56. That is the answer. Just put 56. You don't have to put any units. So our answer is what? 56. That's that for that. As simple as that. Is it hard? No. So let's go to percentage composition. Now we have this question on percentage composition. So they say calculate the percentage composition of each of the elements in this compound. So you have this compound CaO. You see, the first thing is that before you can calculate the percentage composition, first, you get the relative molecular mass of this compound. That is calcium plus oxygen. Remember, calcium is 40. You are not giving, but I will tell you. You can just write it down somewhere. Calcium is 40. Oxygen is 16. So I have 40 plus 16, and that's equal to 56. Okay. So therefore, you have to calculate the percentage of calcium here. Also, you calculate the percentage of oxygen here. That's why they say percentage of each of the elements. Okay. So what's the percentage of carbon? This is what you will do. Pay attention. What is the mass of calcium in this compound? That's 40. So you see 40 over the total. What the total relative molecular mass? That is 56. Then, since you are calculating percentage, you multiply it by 100. And what would that give us? I have 40 divided by 56. Then multiply that by 100. So what do we get? We get 71.4%. That's it. Next, percentage of oxygen. So what's the mass of oxygen in this compound? That's just 16 over, what is the total? 56, then times 100. That's all. So what we have, 16 divided by 56 times 100. So we have a 28.6%. That does it. That's for the first one. Now the second one, we are asked to calculate the percentage of oxygen in this compound Al2SO43. So let's go. Remember, I have 2 aluminum here, I have 3 sulfur, I have 12 oxygen. So this is 2 times aluminum is 27, sulfur is 32, and oxygen is 16. So you will know it the way I'm saying it. Some people ask me, how do I know it? You know, it's been long, so you keep on getting used to them, don't worry. So this is 54, this is 96, and this is 12 times 16, this is 192. So if I add everything together, what do I have? Plus 96 plus 54, I have 342. That's the relative molecular mass, 342. So therefore, percentage of oxygen is what? Now pay attention. Can you tell me what the total mass of oxygen in this compound is? 12 times 16. Did you see? You have to trace oxygen in this compound. Because I have 12 oxygen there. So the total mass of oxygen here is 12 times 16 that I have it. That is everything here. Then over what is the total? 342. Then times 100. Do you see that? So normally that 12 times 16 is 192. So you can just get 190. That is 192 that is there. So let me write 192. So I have 192 divided by 342 times 100. So divided by 342 then times 100. So we have 56.1%. So that's our answer. As simple as that. So thanks for watching this section. Okay, so let's solve this question. They said hemoglobin contains 0.33% by mass of iron. There are 2 atoms of iron per molecule of hemoglobin. So what is the relative molecular mass of hemoglobin? So solution. So this is what we are going to do. You remember that. Let me just give you a formula for percentage composition. Of course, it's what you know, but we don't put it in formula way. So let us make the formula with that. So the percentage of an element is equals to, well, number of atoms of the element times, you know, let me say the atomic mass of the element over the total relative molecular mass of the compound, then times 100. Okay, that is when we want to calculate the percentage composition of an element in a compound. Let's look at the number of atoms. For example, I have Al2O3. If I want to calculate the percentage of oxygen, remember I will say, you know, 3 times 16 over the total molecular mass of all these. So this 3 represents the number of atoms, and this A represents the atomic mass of oxygen. So this is just the formula to do that. Now, so let us now move on. See, we want to calculate the percentage. They said the percentage of iron is 0.33. So I have 0.33 equal to what number of atoms of iron in that hemoglobin? It is 2 times what is the atomic mass of iron? That's 56. So 56 over, this is relative molecular mass. Are you there? Then times 100. So we want to get the relative molecular mass. Okay, so this question is on OAU post UTME. Are you there? That's where this question is gotten from. So let's do that. So we have 0.33 equal to, you know, 2 times 56 times 100. That will give me 11200 over RMM. So if I cross multiply, I'll have 0.33 RMM equal 11200. So to find RMM, divide both sides by 0.33, divide both sides by 0.33. So this will cancel this. RMM is equals to, so divide by 0.33. So the relative molecular mass of hemoglobin was 33939, approximately 33939. So this is what I have. That's that for that. So thanks for watching.